is how gravity is communicated from place to place. Warps and curves in the fabric of space, the Earth too, kept in orbit because it is rolling along a valley in the curved environment that the sun creates. That is how gravity works. Now, Kaluza got wind of this idea, as did the whole scientific community. But Kaluza, when he heard of this idea, began to think. He said, look, if Einstein had this tremendous success by describing the force of gravity in terms of warps and curves in space, and in fact, space and time, as we'll talk about later, maybe I can play the same game and describe another force of nature in a similar language. Maybe put them together. Because at the time, gravity was one force, but another force was the electromagnetic force. So Kaluza said, what if gravity is warps and curves, and the electromagnetic force is also warps and curves? The problem was, warps and curves in what? Einstein had used up space and time. There didn't seem to be anything else to warp and curve. So Kaluza said to himself, what if there are more dimensions of space than we know about? What if there's one more dimension of space? So what he did, what he was doing at his desk, was he took Einstein's equations that were derived and formulated in the context of 3 dimensions of space and 1 of time. He said, what if there are 4 dimensions of space and 1 of time? He writes down the equations, and here's what he finds. He finds some of the new equations to be exactly the ones that Einstein had for 3 dimensions and 1 of time. But because he had an additional dimension of space, he had an additional equation. And when he looked at what that equation was, it was exactly the equation that Maxwell had written down years before for the electromagnetic force. Wow. He found, and what made him so excited, was that he had put gravity and electromagnetism together by imagining that there was one more dimension of space that for some reason we don't see. Now that was the small detail. If there is an additional dimension of space, where is it? Why don't we see it? Now, Kaluza himself didn't really have an answer for that, but in 1926, Oscar Klein suggested an interesting possibility. He said, look, maybe dimensions come in 2 flavors, 2 varieties. There, say, is the big variety that we can easily see, left, right, back, forth, up, down, but maybe there are additional dimensions that are curled up, really tiny, and they're so small that they're all around us, but we can't see them. Maybe that's where there could be additional dimensions of space. What would that look like? So just to get a sense of that, this little analogy looks at a traffic light supported by a cable. From a distant vantage point, the cable looks one-dimensional because we don't have the visual acuity to see the circular part that wraps around the cable. But if we zoom in and take the perspective of a little ant, the ant is so small that it can walk along the cable, but can also walk around the cable. And I do hope you appreciate this visual because it took so long to get these ants to do this. But there you have it. A dimension that's small can be difficult to see compared to big dimensions that are far more obvious. Now, that, of course, is just an analogy. What would that look like not for an object in space like the cable, but rather space itself? So let's take a look at that. So the idea would be this. Here is 3-dimensional space. I can only put 2 on the screen. If we go smaller and smaller and smaller, the idea would be that if you go small enough, you can encounter additional spatial dimensions. Anything not in the grid are dimensions that we can't see. Additional dimensions that are curled up. If you have a really ultra-microscopic ant down there, it can walk in the grid part, the part that you and I know about, but the ant is so tiny that it can walk around these curled up dimensions that you and I just are not aware of because they're too small. They're all around us, but they are just too small. That was the idea. Now that was 1926. Einstein himself got very excited about this idea, began to work on it. The problem was when people started to analyze this in detail, this possibility of extra dimensions in greater detail, they found insurmountable problems. They couldn't get the electron to fit into the theory in the right way. all sorts of problems of detail of that sort, and ultimately the idea was dropped by the 1940s or so. Interesting idea, it basically went away. Until something quite dramatic happened in the 1980s. In the 1980s, people began to pick up the trail that Einstein had left off in 1955, the search for unified theories, much as Kaluza's work was trying to put gravity and electromagnetism together. Physicists took up that charge once again with various theories that you'll hear something about tonight, supersymmetry, and one in particular called string theory. And in string theory, the idea of extra dimensions comes roaring back. So just to give you a feel for what these